Sir, I have doubt in what is it? Cubic expansion, sir. Expansion and expansion in liquid and gas.
Page number.
Page number 35, sir.
Yeah, cubic expansion increase in the volume, right? Say, suppose you take a
Uh,
thin wire, okay,
hmm.
and then heat it. The length will increase, right?
Hmm. Yes, sir.
Okay. Next is take a thin sheet,
Okay.
and increase the heat or heat it, so it'll become bigger sheet.
Okay.
Okay. Next is to take a volume like a box
Hmm.
or a cube. Okay, and then you heat it, the volume will increase.
Hmm.
Okay, so this is cubical expansion. See, even in this case, if you take this cross section of the wire, it will be a small circle like that,
I'm
right?
off.
That circles, but those details are not required because it's a thin wire. You can
Hmm.
only consider change the length. If you take a
Hmm.
thin sheet, it will have thickness, so actually volume is also increasing, but you don't have to think about it because it's very small. Just the area
Okay.
expansion is enough. But if you take this final thing, volume, there is no restriction. You are considering all the three dimensions.
Hmm.
So when you heat it, the volume will increase the V2. Initial volume is
Hmm.
V1. So there's the increase in the volume.
Okay.
So that is delta V. It's proportional
Hmm.
to the original volume and the amount of increase in temperature.
Okay.
See, the increase in the volume delta V will
Hmm.
be more if the volume is more. For
Hmm.
example, if 1 meter cube
Hmm.
expands to 1 meter cube plus 10 raised to minus 3 meter cube. If you take the same thing of size 2
Hmm.
meter cube, then expect the volume to 2 meter cube plus 2 into 10 raised to minus 3, right?
Yes, sir.
Same for linear expansion. If you take 1 meter and say it
Hmm.
expands to 1.01, if you take the same thing as 2 meter, you will expect it to increase to 2.02 because 1 meter will increase by 0.01. Second 1 meter will also increase by 0.01. So the total increases 0.01 here and 0.01 here, which is 0.02. Okay, so here also change in length, delta L, is proportional to the original length. Okay, so delta is proportional to the original volume, which is called V naught, and it's also proportional to the amount of temperature rise, delta T.
Okay.
If you increase by 5 degrees, change in volume is say 2. If you increase by 10 degrees, or change the volume will be 4. Okay, so these two can combine and write as delta V is proportional to
Hmm.
V naught into delta T. And this constant proportionality is a coefficient of
Hmm.
volume expansion. Or here we have put alpha V.
Okay.
Alpha means coefficient of volume expansion. Linear expansion is alpha L, alpha A, yield expansion. So the basic idea is this one. Change in volume is proportional to the original volume. You not put
Hmm.
that. Okay. This is the step. This is the first step is proportional to the original volume and also proportional to the temperature rise. So these two can combine right as proportional to this one. And the constant proportionality is alpha V.
Okay.
If this what you said is for a solid. In the
Hmm.
case there will be a container. So
Hmm.
if the container expands, then you have to be you have to take account of that also. Gas, you need a closed container.
Yes, sir.
Hmm. The solid is easy to understand. So first understand that. After that, liquid and gas. Superficial is same as area.
Hmm.
Anything else?
No, sir. Sir, 1 second, sir. It's telling me to rejoin.
Okay.
1 second. Sir, am I audible?
Yeah.
Ah, sir. Sir, can you teach me the equations of nuclear physics another time, sir? One example, sir. I'm having doubt in that.
Which one?
In page number 76, sir.
Here is the example.
This is the example, sir.
This one.
Ah, actually, for the atomic number, should we multiply with 4 or 2, sir? That's my doubt.
Atomic number.
No, sir. They told me that in the atomic number we need to add 4, and for the mass number we need to subtract 2. So like I get confusing over
No, no.
here.
See, this is a beryllium nucleus, right? It has got
Yes,
4
sir.
protons and then
Hmm.
5 neutrons.
Hmm.
Okay, this mass number is sum of proton and neutron.
Okay.
Okay, here there are 2 protons, and then so obviously number of protons will increase to 6.
Hmm.
It should match, right? And then the mass number will
Uh,
be 13.
hmm.
Okay, and here uh, proton is same, but here one neutron is coming out
Hmm.
from the nucleus.
Okay.
So here it is 7 neutrons, right? Here it is 6 neutrons.
Yes, sir.
So the neutron from inside the nucleus is coming out.
Okay.
Okay.
Mm,
So if you see, the initial thing is this beryllium 49, and the final thing is this carbon 612. Okay.
mm,
And what you're using is alpha particle H2, and the extra
mm.
thing in the product is neutron.
Okay.
So this is the one that's creating the reaction, alpha particle, and the you can say byproduct is
Mm.
neutron.
Okay.
Okay, this will cancel in between step C30.
Okay, sir.
So here we are hitting the beryllium missing.
Mm,
Okay, they're combining these two and writing a single equation. Yeah,
mm.
it's nuclear reaction only you have to consider the nucleus. So this means the
Ah,
nucleus has got 4 protons and then
mm.
5 neutrons. Here the nucleus has got
Okay.
2 protons and 2 neutrons. So
Okay.
number of protons is 4 plus 2, 6. That's matching here.
Mm.
And the number of neutrons is and mass number is 13. That's also matching. In this
Okay,
step,
sir.
the neutron from the nucleus is coming out.
Mm.
When you put the star, it means it's unstable.
Okay.
Like two hydrogen molecules stable, right? Suppose I force a third hydrogen molecule to form a bond, it might form for a short time,
Mm.
but after that, a hydrogen atom will come out of that hydrogen molecule.
Mm.
Okay, similarly here, if I try to push the seventh neutron
Mm.
inside this one, it will be there, but it won't be stable. It will just come out.
Okay.
So this is a stable thing.
Mm.
So this is called projectile, which is because this thing will be you throw this helium atom and
Mm.
penetrate the beryllium nucleus. So this is projectile is something which is thrown. So this is the projectile, and this is the byproduct or ejected particle, neutron.
Okay.
Coming these are running like this. So this you are throwing into this beryllium nucleus, and what is coming out is a
Ah,
neutron. So neutron is a ejected particle. So on the product side, you can get alpha particle also, which is helium nucleus.
mm.
This is alpha decay, and then beta means electron will come out. But the interesting thing is this electron is not coming from the electron shell; it's coming from within the nucleus. Here there are 15 protons. The number of protons increased to 16. Okay, that means here there are 17 neutrons. Here there are
Okay.
16 neutrons. So this neutron here has got converted to proton plus electron,
Okay.
which is coming out.
Mm.
Okay, so conversion of neutron to proton is within the nucleus. That's nuclear reaction.
Okay.
This electron has come from within the nucleus.
Mm.
So that is the interesting thing. So this is beta decay. Beta decay means electron is coming out. Alpha decay means
Mm.
helium nucleus is coming out. A group of 2 protons and 2 neutrons. That's basically helium nucleus that's coming out from the
Mm.
uranium nucleus. That's alpha decay. This is beta decay. Third one, just
Mm.
energy will come out. Nothing will, no mass. Only the energy is coming out.
Okay.
The charge of alpha particle is 2 protons. Charge of beta particle is 1 electron minus E. This is plus 2E. And then
Okay.
this is not a part, it's just a radiation. Like, right. So there is no mass or charge, zero charge.
Uh, okay.
So Max, the answer sheet they are given.
No, sir. Actually, they haven't.
When they will give.
Mostly after the pre-board, I think so, sir. All the three exams completed, they'll be giving, I think.
So when is the final exam?
For the pre-board, sir.
No, no, final exam. Board exam.
It's on 1 second, sir. Let me take my timetable.
March something, right?
March only is starting there. Let me tell you the date, sir. March 11th, sir.
Okay.
From March 11th to April 6th, sir.
When is max exam?
On 25, sir.
Science,
Science is 30, sir.
March 30.
Yes, sir.
Oh,
For the max exam, we have 9 days leave, and for the science, we have 4 days leave, sir. So is the class is over?
yeah, yeah.
Thank you, sir.